everything in between. So I think it's a great start. So for our next presenter, it's Dr. Dave Klurfeld. Dr. Klurfeld is a highly respected and very productive nutrition researcher. He was on faculty at the Wistar Institute and the University of Pennsylvania Medical School for 15 years. He left that position to become a department head. I'll never understand that move, Dave, but he went to become a department head at Department of Nutrition and Food Science at Wayne State University in Michigan. He was there for 11 years, and then since 2004, he has been in the National Program Leader for Human Nutrition in the Agricultural Research Service of the U.S. Department of Agriculture. Dr. Klurfeld's research has focused on the influence of dietary fiber, dietary fat, and caloric restriction on colon cancer, on heart disease risk. He's published over 185 peer-reviewed articles and book chapters. He was editor-in-chief of the Journal of the American College of Nutrition for 6 years and is currently an associate editor for the American Journal of Clinical Nutrition. He's also a member of the National Institute for Diabetes, Digestive, and Kidney Disease Advisory Council. I've known Dave for many, many years, and I've always had the greatest respect for Dave. He's a scientist who follows the data and who bases his conclusion only on what the science tells him. And today, you're going to hear what the science tells him about, does red meat really increase colon cancer risk? Please welcome Dr. Dave Klurfeld. Yes, it's a great difficulty. What the heck? Did it that way. Is it showing? Oh, it is. Okay, it is. Go ahead. All right. Should look at the screen sometimes. Gotcha.
Well, thanks very much, Dan. It's a pleasure to be here, even though it's freezing cold for somebody from Washington, D.C. It's a tough act to follow tomorrow. I agree with everything she says. Unfortunately, she didn't write, at least I didn't read a column of yours prior to 2.5 years ago that talked about changing your mind. I don't know if that's a more recent topic, but I went to France for 10 days 2.5 years ago to be part of the World Health Organization's International Agency for Research on Cancer working group on the carcinogenicity of red and processed meats. So I was one of 22 people from 10 different countries that spent 6 months preparing to be in France for 10 days. And there were 22 experts who were all self-nominated, including me and 2 other people from U.S. federal agencies, one from NIH, one from FDA, and me from USDA. There were 11 epidemiologists on the panel out of 22. So that group of people tended to drive the decision. And I'm going to tell you why that shouldn't have been the case. I do need to point out, even though I did this with all sorts of ethical approvals and I was considered on official duty at the time, the WHO told all of us as soon as we got there, you're not there representing your own agency. You're representing yourself as an expert in this field. So I will tell you from the beginning, everything I say this morning does not represent the USDA or the Agriculture Research Service position. So Dan asked me to, this actually works. Dan asked me to talk a little bit about the nutritional value of beef. So got one slide on that because you can summarize it really in one slide. And the point here is the first, those bars shows the calories, and if there's a longer bar there, that means you're getting more bang for your buck out of those calories. So you can see protein from just 3 ounces of beef provides half your daily requirement for protein. And it's complete protein. All the essential amino acids are there. You can see that the fat is just barely longer than the calorie bar. And that's also true for saturated fat. You know, it's not this disproportionately killer food that's slamming arteries shut in your heart, which was the official, in fact, still is the official USDA position, but it was the position for much of the nutrition field for decades. And we're just starting to crack that as probably untrue. But then you look at all the micronutrients below there, the minerals, B vitamins in particular, and vitamin A is not on here. Organ meats tend to be higher in vitamin A, but muscle meat also contains significant amount of retinol. So 3 of the most prevalent nutrient deficiencies in the world are vitamin A, iron, and zinc. A few ounces of beef a week is enough to take care of those kinds of nutritional deficiencies. On the other hand, much of what you'll read in scientific studies is what's wrong with meat. And this is actually a relatively recent review article that tells you all of the things that eating meat does bad to you. It gives you obesity, it gives you type 2 diabetes, gives you heart disease, gives you cancer of 17 different locations. It increases total deaths. Now, just imagine if you had developed a drug, you're all working for a pharmaceutical company this morning. You've developed a drug that cures all of these things. Your boss would fire you on the spot because you're lying. It's not possible. And just think about that from a cause and effect relationship, if somebody comes to me and says, beef does one thing or 2 things really serious to you, I would listen to that. But if somebody comes and says beef does 24 different bad things to you that are totally unrelated from a biological mechanism, that's kind of a stretch. So, talking about stretches, so I spent 10 days in France with these 22 folks, and unfortunately this is a little bit fuzzy, but this is actually the fuzzy slide that WHO gave us. And there are 4 categories of classifications on whether a substance causes or doesn't cause cancer. So I want to just introduce this by talking about recently in California, a judge ruled that Starbucks and all these other coffee shops have to put a warning on coffee cups that drinking coffee causes cancer. And the reason for that is because roasted coffee contains acrylamide. And acrylamide is a carcinogen. But it takes 100,000 to 1,000,000 times the dose that's in a cup of coffee to induce cancer in a rat. Now, the WHO has actually reviewed coffee in the 1980s, and they concluded that it probably caused cancer. Well, last year, because of 25 years of people screaming, "What are you, nuts?" they re-reviewed coffee and they said, well, there isn't enough evidence to conclude that coffee causes cancer. But a judge in California has concluded that because there is a carcinogen in coffee, it causes cancer. So the next time you go to California, there's going to be a warning on your Starbucks. So there's 4 categories here. Sufficient evidence, that means you can actually reach a conclusion. Limited evidence, you probably can't reach a conclusion. Inadequate evidence means we don't know anything, and as Tamar pointed out, we don't know anything about nutrition. You know, when I was an assistant professor, I was sure I had all the answers. By the time I got to be a full professor, I didn't know anything about what caused anything. I need to point out the bottom category here, evidence suggesting lack of carcinogenicity, is a really unique observation to the International Agency for Research on Cancer, or IARC. They've evaluated about 1,000 different things in the 50 years they've been doing this, and exactly 1 chemical has been in category 4, that it doesn't cause cancer. So the staff there essentially finds if they're reviewing it, you're guilty until you're proven innocent, and there's not much that can prove you innocent. And the limited evidence category actually is subdivided into two groups, that it's probably carcinogenic or possibly carcinogenic. Group 1 has things like smoking, tobacco, ultraviolet light exposure, radionuclides, things like that. So processed meat ended up in that category. Red meat ended up in the probably carcinogenic area. Possibly carcinogenic includes chemicals that Dan and I have used to induce cancer in rats. It's just amazing how this system doesn't seem to comport with the facts. And I have to say, I had a lot more faith in this system until I saw how the sausage is actually made. So we were there for 10 days. We came home, and 2 weeks later, Lancet Oncology published a 2-page summary of our conclusions. And just last week, 2.5 years after we met, the 511-page monograph was published online without a peep. I actually searched Google News earlier this week, and I couldn't find a single mention of the posting of this report. And I haven't had a chance to read 511 pages yet to see, because the authors of the report, the working group, didn't see it from the time we left France until it appeared last week. We had no input into the actual writing of the report. Now, the conclusions are unchanged. I can vouch for that. But I voted against the majority of the committee, and so did several other people. This was not a unanimous or near unanimous decision. So this is actually the first paragraph of the 2-page report. And there are a couple of problems with it. Number one, they didn't even know how to define red meat. They were going to use the definition of the percent myoglobin in meat. And there were actually a half a dozen observers from the meat industry there who were allowed to speak if they were called upon by the chair of the committee. And there was a woman observer who actually had sitting in her lap a textbook on meat science. And she got up and, I'm paraphrasing, said, in the nicest way possible, "You people have no idea what you're talking about." And she read to them the definition from a textbook of what red meat is. And so after 3 days of deliberation, the subgroup that was in charge of definitions completely reworked their definition. And the same thing happened for processed meat. They talked about grinding, curing meat. And that was it. So they didn't specify that there's a half a dozen ways of preserving meat, like curing, smoking, drying, fermenting, which create totally different byproducts. They had no idea of this. And it just blew me away that people in charge of defining this had no clue of how food is made. And in fact, as Dan said, I was a chair of the Nutrition and Food Science Department for more than a decade, and the most important lesson I got was that nutritionists in general have no idea how food is made, and food scientists have no idea what food does to you when you eat it. So you can't read it from the back of the room, but so I've underlined in red here, the epidemiologist subgroup evaluated 800 studies, and that's absolutely true. One night they were there at the WHO building till 3 in the morning, and we started every morning at 7 o'clock. So these people really worked really hard. The problem, though, is at the top. The decision that red and processed meat is causal for colon cancer is only seen in a handful of studies of those 800. Because the decision is not based on carcinogenicity in the kidney, in the bladder, in the stomach, anywhere but the colon. And they used 14 studies for red meat, and only half of them pointed towards a causal relationship. And for processed meat, 2/3. And you see 14 and 18 cohort studies. Well, they're all the same cohorts. It's just they asked a different question. Did you eat red meat in the last year, or did you eat different kinds of processed meat? Or simply, did you eat processed meat? And there are lots of problems on how they reached that conclusion. So IARC does not use epidemiology alone, but the epidemiology drove the bus almost entirely. They used mechanistic evidence to support this. I was on the subgroup that reviewed all of the animal data. And the conclusion was that the animal data do not provide any useful evidence that red or processed meat is carcinogenic. And in fact, of all the studies reviewed, there was one that said red meat contributed to carcinogenicity. Everything else said it did not. In fact, there were a couple of studies on the right-hand side here from one of the members of the working group's lab, where they fed 5% bacon in a diet to rats and gave them a chemical to induce these precancerous lesions, which Dr. Gallagher will explain to you if you don't understand. They're called aberrant crypt foci, significantly reduced in 2 separate papers by feeding bacon. The only time those were increased was on the left-hand side, when at the bottom, when rats were fed 3 times the amount of protein as blood sausage. And I didn't know what blood sausage was made from until I spent 10 days in France. And blood sausage is 80 to 90% blood and 10% some kind of starch to hold it together, and some spices and salt. And that's pretty much it. And I'm still not going to taste it, no matter what you say. But so you're feeding 3 times the amount of protein, and if you're feeding 3 times the amount of zinc or iron to a rat or to one of you, you're not necessarily going to be the healthiest person. But you have to feed it in a calcium-deficient diet to see those adverse effects. And the subgroup from animal studies wanted to put a note to the reader in it that this was an unusual design. And the person who was responsible for those yelled at us so much that we simply withdrew our proposal to leave that note in the lesson, in the monograph, so it's not there. But they had a long list of potential mechanisms. Mechanisms simply establish plausibility, that it's possible. They don't establish causality, which is what IARC claims. And that's all they have to back up the epidemiology. So there was news around the world. As soon as that article came out in Lancet Oncology, sales of red meat and processed meat in the United Kingdom dropped by 25% for the 2 weeks following that. I wasn't able actually to get sales figures from the United States, but it wouldn't surprise me if they dropped temporarily. And this is essentially what happened. There was a lot of pushback, actually, and a lot of adverse studies, or not studies, but reports in the news media on this. And as a result, 3 days later, the WHO had another press conference to say, well, it's not quite as bad as the working group says it is. We're going to figure out how to incorporate the right amount of red and processed meat in your diet. And they said that we have a standing group of experts who meet regularly, and sometime early next year, meaning early 2016, that was 2+ years ago, that we're going to tell you how you can do that. And there's never been a report from this group. I don't know if they've never met or they're just not reporting it. So one of the standards of putting together dozens or hundreds of papers is to use systematic reviews and a meta-analysis. Neither one of those steps was done by IARC. So the currently worldwide accepted standards were not followed for this process. So the grade system was done by Gordon Guyatt and his colleagues at the University of Ottawa. GREAT is an acronym for, you can read it at the top yourself. And it's widely accepted. And the WHO has, in theory, been using it for years. IARC is part of WHO. They are semi-autonomous, so they don't use it. But the WHO uses it, and 55% of the time, their strength of evidence grades don't agree with the grade strength of evidence. So WHO says they use it, but not really. But there are problems in risk assessment. So relative risk is what scientists use to evaluate the risk of people exposed to the lowest amount, like the vegetarians who eat no meat, and the people who are eating beef twice a day, the highest quintile, or whatever, however you want to divide these. Most of these epidemiology studies are dividing people into 5 groups of different levels of intake. And just to compare relative risks of eating processed meat, it goes up by 18%. So the relative risk is 1.18. But let's look at some of those other well-known established carcinogens that people really agree on, like cigarette smoking. The relative risk is 10 to 30. One of the few foods that truly is inarguably associated with cancer is aflatoxin-contaminated grains. It's a huge public health problem in parts of Africa and Asia. 6-fold increased risk compared to 1.18 from processed meat. The problem with relative risk, it has no relationship whatsoever to absolute risk. So if you're a non-meat eater, for your entire life, your relative risk of getting colon cancer is 4 in 100. If you eat processed meat every day of your life, your relative risk of getting colon cancer, your absolute risk, is 5 in 100. That's the that's 0.8 difference between those two numbers, is that relative risk of 1.18. Now, the problem for IARC is they told us and the world that we're identifying the hazard, not the risk. But they used relative risk to identify the hazard, which, to my way of thinking, is a classic example of circular reasoning. And because the epidemiologists spent every night working late and evaluating 800 studies, the rest of the committee had no opportunity to review their work or what they wrote. And for the other subgroups, every line was parsed by the full committee, and we wordsmithed it in the full group. So many of you have seen these types of evidence pyramids, and meta-analyses tend to be at the top of some of these, but randomized controlled trials are the gold standard. There you can really establish cause and effect. And that's really the key issue for these types of conclusions. Almost everything studied by IARC is here. Uncontrolled longitudinal studies, the cohorts like EPIC, like the Harvard cohorts, the nurses, health professionals, and so on, and some cross-sectional studies here. And this is what you can conclude from that. There are signs that there might be a relationship. You cannot conclude cause and effect from this. And in fact, the conclusion we came to is an expert opinion, which in every pyramid is the lowest form of evidence. So there are lots of issues. All of these large cohorts, 100,000 people or more, use a food frequency questionnaire. And so the critical question is the food frequency questionnaire reliable? How many people have actually filled one out? Anybody? Handful of folks. Well, until I did it myself, I had no idea how hard it was and how iffy it is to fill one out. Because what I've eaten for the last 2 weeks colors what I think I've eaten for the last 12 months, because that's what they're really asking about. And so NIH has developed their own questionnaire. It's got 124 food items in it, 3 portion sizes. A lot of FFQs don't even ask about portion size. They simply ask, well, how often have you had hamburgers in the last year? And, if it's summertime, you might be having it more than in the wintertime, and so on. There's no thought about seasonality of intake. But there are biomarkers for a limited number of foods and nutrients. And this is one of the problems in the nutrition world in general. So you can use doubly labeled water for energy intake, and you can use urinary nitrogen for protein intake. And here's an exact quote from Arthur Shatskin. The FFQ cannot be recommended as an instrument for evaluating the absolute intakes of energy and protein in relationship to disease. And energy and protein are the 2 primary indicators of meat intake. So here's people from the NCI saying, you can't use our questionnaire, and their questionnaire isn't any different from any other FFQ. And Paul Rosenbaum's a statistics professor at the Wharton Business School in Philadelphia at University of Pennsylvania. He's a really smart guy. And this is part of the problem, that everybody agrees, as Tamar was talking about, that, we're right, we know what we're talking about, and those other guys who disagree with us are just dumb. But consensus and repetition don't make weak evidence strong. And that's part of the problem. There are established ways of getting from association to causality. And they've been in the literature for 50 years, but they weren't followed by IARC. So Sir Austin Bradford Hill gave an after-dinner speech to the Royal Society of Medicine in 1965. And it's freely available through PubMed. You can go there, download it, and enjoy it. Well, I can tell you this has been cited more than it's been read, because people don't talk about that. Sorry. These are the 9 criteria. And if it's a strong effect, like cigarette smoking, you can be fairly certain about it. And Hill said strength was the most important factor, but it needs to be consistent in the same direction, it needs to be specific, needs to be exposure before the disease, should be a dose response, and then there are a bunch of other things in there. And this is what we have for meat. We're missing the majority of those factors. So, I don't think we've done our homework adequately to say that meat causes cancer. And one of the main reasons for that is a paper from the NCI that I read in 2009. And I wrote a review about meat and health open questions a couple of years ago in a journal, and I drew this graph, and it's a little hard to follow, but it's really important. For me, this was the aha study that says, now I understand there's a huge problem here that nobody can fix. So there were multi-page tables in this paper for men and women linking all different causes of death to different levels of meat intake. So Q1 here is people who don't eat red meat at all. Q5 are the people who eat the most red meat. And it doesn't matter what the most red meat is in this study. The square boxes are all above here, this is the relative risk of 1 for the lowest group. If you're going up, that means you get an increased risk. If you're going down, you have a decreased risk of whatever the disease is. And these are 70,000 causes of death. So we think these are highly statistically significant, and almost every line on this chart is significantly different from the people who are vegetarians. So as you're going up, you're getting a dose-dependent increase in all mortality here in this pink, heart disease in the green, accidental deaths in that light blue, cancer in the brown. But look at this, all other causes is way more. All other causes is over here. infectious diseases, ulcers, COPD, which is due to almost exclusively to cigarette smoking, liver and kidney disease, Alzheimer's. So why would you be at twice the risk for getting all of these other things from eating red meat? And why would eating white meat, which is fish and poultry, significantly protect you from all those diseases?
It's the schmuck index.
Thank you. So either there are multiple confounding variables that are affecting what appears to be a significant relationship, or this is not a large enough signal to detect it from all the noise in these kinds of studies. And so I'll give you a couple of examples. Sandra Greenland is a retired epidemiologist / statistician out in Southern California. He did this editorial in the International Journal of Epidemiology about how multiple comparisons are a problem. And Sandra gave this example in his editorial that if you have 100 food items, 40 nutrients or food constituents, and 50 diseases or risk factors, you get 120,000 outcomes just by multiplying those three numbers. At the 5% significance level, 6,000 of those could be false positives. But he was being generous to the epidemiologist because the typical food frequency questionnaire has 125 foods, 65 food constituents, 50 is generous, it's probably more. But just by changing those numbers a little bit, you quadruple that number to over 400,000 potential outcomes. And 20,000 of those are potentially false positives. So this is really a problem. Now, when I was in France, I raised the issue with the committee that there were two intervention studies that argued against red meat being causal. And I'm going to show you this in the following two slides. The polyp prevention trial was done at multiple locations around the country, sponsored by the NCI, done 15, 20 years ago now. Almost 1,000 people in each group, people who had had a colon polyp identified on colonoscopy, therefore you're at much greater risk of getting a second one soon. So half of them were told, go home, follow your usual slob American diet. The other half were told, go home and eat a healthy diet. More beans, more whole grains, more fruits, veggies, and significantly less red and processed meats. They were followed for 3 years. Everybody had a repeat colonoscopy, and the relative risk of recurrent polyps was identical in both groups. There wasn't a hint of a benefit. So this is the precancerous stage of colon polyps. You're at greatly increased risk of getting colon cancer if you have a colon polyp, and that's why you're supposed to get a colonoscopy so they can snip it out if they find one. So maybe it doesn't work at the precancerous stage. So NCI did the most expensive nutrition study ever done. The Women's Health Initiative cost the government taxpayer $750 million. And the nutrition part of that was $450 million. 50,000 women followed for 9 years. 30,000 just told to go home and eat their regular diet. 20,000 told go home and follow this prescribed low-fat diet. How do you get to a low-fat diet? You cut your meat by 40% in this study. And there are two lines here, if you can't see it. There's a dark black line and a lighter gray line. It doesn't matter which line is which because they overlap. There's absolutely no benefit for colon cancer from following a low-fat diet. So the committee epidemiologist said to me, well, neither one of these studies was primarily designed to look at meat. Well, that's also true about all the epidemiological studies. Not one of them was designed specifically to look at meat. So it's a problem that we have intellectual biases, confirmation bias that we bring to these discussions. And in fact, 6 months after the editorial on, or the summary report that was published in Lancet Oncology that I'm listed as a co-author on from our working group, there was another editorial in Lancet Oncology saying, IARC is doing a lousy job. And it's the center of pronouncements that are duly, this is typical Brit speak, duly rounded on to explain the consequences. In other words, what the hell are you guys doing? And they basically said in their editorial that they need to establish a better system because they're going to be criticized until we have an internationally accepted system. And let me just give you very quickly a couple of examples. Coffee and heart disease 40, 50 years ago was inextricably linked to heart attacks until they realized the correlation between coffee drinking and cigarette smoking was so high that once they controlled for exposure to tobacco, coffee actually is protective against heart disease. Same thing for coffee and pancreatic cancer. They just chose, and this was in the New England Journal of Medicine, they chose the wrong controls for that particular study, and it was done at Harvard. So we have a graveyard of studies in nutrition and chronic disease endpoints. Vitamin C, curing, fill in your favorite disease. Vitamin E, heart disease. Vitamin E, cancer. Vitamin E in ulcers. Beta carotene in cancer, strong enough so that NCI sponsored multiple controlled interventions with carotene supplements, and then they found that beta carotene significantly increases the risk of lung cancer if you're a cigarette smoker. If you're a non-smoker, it doesn't do anything, good or bad. Selenium, same thing. Observational studies, people exposed to a lot of selenium, in theory, have less cancer. They did the SELECT trial testing vitamin E and selenium. Selenium increases the risk of skin cancer significantly. So there's still a lot of open questions about meat, and everything I've said today doesn't mean that you can go home and eat as much beef as you want. That's not what my message is. My message is we haven't proven a link between beef and cancer, certainly not processed meat and cancer, because there are multiple kinds of processed meat, and they were all lumped together as a single entity. We don't know, in fact, we do know that for most high meat eaters, they're eating fewer whole grains, fewer fruits and vegetables. Is it simply a deficiency of those nutrients, a lack of fiber in the diet? Is it simply that the signal is too small? You know, is there a real effect, but we just can't detect it? And that's certainly a possibility that I'm willing to acknowledge. Or is it simply that the people who eat the most meat just say, I don't care about your recommendations, I'm going to do whatever I want. So I'm going to exercise less, I'm going to weigh more, I'm going to drive my car without wearing a seat belt. You know, I'm a libertarian, don't tell me what to do. 3 libertarians in the audience. Okay, so this is my final slide. The majority of the working group went to the left. It's simple answers, but a wrong conclusion. A few of us went to the right, complex answers, but I think we were right. Thanks for your attention.
I think we can take a couple quick questions, but again, we will have Dave and the other speakers this morning on a panel in the afternoon. But if you have a quick question, we can entertain that now. Anybody?
It's actually kind of a joint question.
A what question?
A joint question for
Oh, I
the
thought
two
you said-
speakers.
Oh, I thought it-
First of all, I want to thank you both for very engaging presentations. But my question is about the reporting of relative risk versus absolute risk, and it's particularly health journalism, and how that distinction isn't usually presented. I'm not sure. I'm not sure many science journalists even understand the difference.
Yeah, I think that's probably the case, but I can assure you that a general interest audience has limited patience for an explanation of relative versus absolute risk. But I do think, and I took notes when David was talking, because I think that some of the data that he presented about how relative risk increases 18% with red meat, and were things that we really understand, it's orders of magnitude larger. I think that there are ways to make that accessible, and it's on my to-do list.
Well, I read a lot of FD articles, and a lot of those articles don't even present absolute risk for, it's all our ratios.
In our favor, in my defense, in defense of my profession, I will say that most papers do not.
I know, that's
include
what I'm
absolute
saying.
risk.
Yeah, I
Right,
agree.
it's not in the paper, and
Right.
so you can't include it. And I've had conversations with scientists about focusing on absolute risk, and the answer is basically, oh, absolute risk, Schmitz. is the thing that matters, because, you know, the question is what will change if you change this behavior. But again, it's the law of small numbers. If you're talking about a minuscule increase in a very small number, it can look very compelling, and it's mostly fun.
Yeah, just Tamar gave a great answer, but just to add a little bit to this, we genuflect at the altar of P less than 0.05, and that's a big part of the problem. Many journals don't consider negative studies worthy of publication, and so you're never going to get a significant risk for absolute risk. You're never going to get a significant benefit from that. And in fact, just last month, John and I and Nidis had an editorial in JAMA that everybody should read, suggesting that we should go to P less than 0.005, because so much is garbage in biomedical literature. Yes, ma'am?
Dr. Cruz.
Okay, thanks. So
I didn't even see Mindy. There you are.
is that when it comes to cancer, people are terrified. And I'm going to ask the audience, I'm going to ask women in the audience to raise your hand if you would stop doing something that increases your risk of breast cancer by 10%. How many of you would stop eating something or would stop some kind of activity? So it's a fair number, and if this audience was over 50 or over 60, I can guarantee that 95% of the women would raise their hand. 10% is enough. People want to know, is it going to increase my risk 10%? I want to know that. So that's an emotional thing because of people's personal experience with loss and grief about cancer that I think has to play into this. We don't just want to know if something is going to increase our risk 10 or 20 times. We want to know if it's going to increase in a small amount.
You're absolutely right. In fact, some of the epidemiologists that I'm still friends with, and I just, I've lost a lot of friends over the years, not just from doing this. But you're absolutely right. That's the argument that my epidemiology friends make. If it's a small risk, because breast cancer, colon cancer are so widespread, a small difference can have a significant effect. But I'm not asking for absolute proof, but I want to have strength of evidence that I can respect, that I can stand behind and say, this is probably true. And I don't think we've done that for red meat and colon cancer.
Great, thanks, Dave.
Thank you.
I think Dave has opened up an exciting new area of research looking at the effects of libertarianism on colon cancer risk. I'm all in on that. So our next speaker is Dr. Karen Jaceldo Sigell, and she completed an undergraduate degree in chemistry and a master's degree in nutrition in Texas. So I'm sure she's wondering what she's doing here today. She earned a doctoral degree in public health at the Loma Linda University of Public Health in California, which is of great interest to me because I was actually born in Loma Linda, California. She stayed on at Loma Linda University to become a full-time research associate for the Adventist Health Study 2, which is an NIH-funded research program with over 97,000 adults in the United States and Canada. And that project is funded by the National Cancer Institute. And at this point, she's now co-investigator on that study. She is an assistant professor in the Department of Nutrition in the School of Public Health, as well as in the Department of Preventive Medicine in the School of Medicine. Her work is primarily focused on research these days with emphasis on nutrition and the health benefits of soy and nut consumption, and more recently on the environmental effects of vegetarian diets. In her spare time, she mentors postdoc fellows and doctoral students, serves on dissertation committees, and helps guide graduate students through the ups and downs of their research projects. So it is a great honor to have Dr. Jaceldo Sigell here today to speak with us on the benefits of plant-based diets, evidence from the Adventist Health Study 2. Please welcome Dr. Jaceldo Sigell. Oh, yours is on a drive? Oh, okay. Okay.
Can everyone see me above this podium? You know, during one of our consultancy meetings, we had all these big-time scientists from Harvard and other famous institutions come to Loma Linda to critique what we do with our Adventist Health Study cohort. I was being introduced around the table and by our PI, Gary Fraser, and he said, "Karen, why don't you stand up so that," because it's the first time you're being introduced to the group. And so then I looked around, I said, "Okay, sure, but it's not going to make a difference." Okay. All right, so thank you for inviting me. It's a real pleasure and an honor to be here. And I can tell you what, the truth is, I'm scared to follow Dr. Klurfeld and also Tamar. She questioned me about the validity of what we do, measuring diet. I mean, so, last night. And I told her last night after dinner, please don't be rough on me. Okay. All right, so several years ago, let me make sure I know how to use the pointer. I think it's the pointer.
Yeah, the green line is
the pointer.
The pointer, and then the buttons go.
Okay. All right. So several years ago, the U.S. News and World Report came up with their list of 10 health habits that will help you live to 100. Okay. Number 1, don't retire, floss every day, move around, eat fiber-rich cereals, get 6 hours of sleep, consume whole foods, not supplements, be less neurotic, and the number 8 on the list is to live like a Seventh-Day Adventist. Okay? So the Adventist Church encourages many healthy habits, and I won't have time to go through all of them, but the church also does health promotion activities within their faith community, which I believe help many church members to sustain these healthy habits for a long time, and thus they live longer and healthier. But today my talk will focus on the dietary aspects of the Seventh-day Adventist lifestyle. Okay, so the Adventist health studies are long-term health studies exploring the links between lifestyle, diet, and disease among members of the Seventh-day Adventist Church, which is a Christian denomination that encourages a vegetarian diet and calls for abstinence from alcohol and tobacco. Adventists are ideal for epidemiological studies in that in their similarity in lifestyle behavior, such as not smoking or not drinking alcohol, reduces the likelihood of confounding that is often present in the general population and other study groups. So the absence of these potentially distorting characteristics increases statistical power and makes other factors such as diet more easily observed. Although the church encourages a vegetarian diet, adherence to this recommendation varies greatly among the church members. Hence, the wide range of dietary habits, from strict vegetarianism to a normal American diet, which is now being called SAD, the Standard American Diet. Okay, this variation is advantageous as it allows investigators to compare the health effects of different dietary practices with minimal distortion from confounding factors that I just mentioned. The two most notorious ones are smoking cigarettes and also drinking alcoholic beverages. So, to date, there have been, before I move on, so just by this alone, when we publish papers, a reviewer will always say, you have to include as a limitation if your study is the limited generalizability of our cohort because of these kinds of behaviors that we can actually control for in the design of the study, whereas most other studies, they have to control for it in statistical analysis, okay? So that, by itself, when you can fix a problem at the design stage of a study, that actually speaks more to the generalizability of your findings to the universe, if you will, or to populations outside of your study, okay? So then, so there has been to date, 5 Adventist health studies based at Loma Linda. Am I showing? Sorry about that. Yes, okay. The first one, the Adventist mortality study, was started in 1958. It was a prospective study of 23,000 California Adventists. The study was conducted at the same time as the large American Cancer Society among non-Adventists in California, and comparisons were made for many causes of death between these two populations. The second major study was designed to determine which components of the Adventist lifestyle give protection against disease. And so we call this the Adventist Health Study 1, or AHS1, and it enrolled over 34,000 Adventists in California. Then you have the Adventist Health Air Pollution Study, we call ASMOG, and that is simply, it consists of over 6,000 California Adventists who were members of AHS1, so it's a sub-study of AHS1. And that study investigates the health effects of long-term exposure to ambient air pollutants with a very little confounding by active tobacco exposure. The Adventist Health Study 2, AHS2, is the cohort that we have now, and it consists of over 96,000 Adventist participants in the US and Canada. It is one of the largest and most comprehensive studies of diet and cancer, and it also is one of the largest dietary studies of Black African Americans, which will help us answer why this group has a disproportionate amount of cancers and heart disease. The Adventist Religion and Health Study is a sub-study of AHS2, okay, consisting of 11,000 Adventists in the cohort. It aims to understand what specific aspects of religion, life stressors, and other health behaviors account for better or worse health, and trace some of the biopsychosocial pathways to health. And this very last one was just inserted recently, and it is the ASMOG Study 2, which is the same cohort as AHS2. Okay, so what have we learned so far? So let me present to you some of the key findings from AHS1 and the Adventist mortality study. So in this slide, this was a study looked to examine the consumption of nuts and risk of fatal ischemic heart disease. And what the figure is telling us that people who consume nuts 5+ times per week compared to those who consume less than 1 time per week has about 50% less risk of fatal ischemic heart disease. And in the same token, we also have a reduction of about 50%, an associated reduction of 50% of high consumption of nuts versus low consumption of nuts for fatal ischemic heart disease. And just to try to respond to some of the questions earlier, it is true that when we report in epidemiological studies, when we report our findings, the proper interpretation is to say that our findings, that a consumption of some kind of food is associated with less or more of a particular outcome, but we cannot really say that it's caused by. And we can't do that because those questions are best answered in clinical trial, and this is not a clinical trial. This is an observational study. Okay, this one is a study that looked at the association between foods and colon cancer. And here at the very top figure, this was done among low white meat consumers, okay? So among low white meat consumers, what this is telling us is that, people who consume red meat weekly compared to those who consume never have actually twice the risk of colon cancer. And then here, at the bottom figure, this is among low red meat consumers. And what this is telling us that people who also consume white meat weekly compared to those who never consume white meat among the low red meat consumers have more than 3 times the risk of colon cancer. And here, also from that same study, we are seeing that people who consume legumes more than twice per week compared to those who consume less than weekly have an associated risk that's about cut in half. And this is a study that looked at the association between food consumption and incident lung cancer. And last night, I almost deleted this because I was confused by these numbers, less than 3 times, and then less than or equal to 1 time per week. So, that doesn't make sense until I looked at the denominator. So here it's less than 3 times per week, and this is per day. And so what we are finding here is that the people who consume at least 1 time per day of fruit has an associated 70% reduction in incident lung cancer, and that there's slightly more reduction if you consume fruits 2 or more times per day. Okay, so this is actually a survival curve. And let me just explain to you that what this is telling us is the probability of survival at a certain attained age. So where the attained age is here on the x-axis and the probability of survival is on the y-axis. So this particular figure is actually showing the survival of California Adventist men and other California non-Adventist men beyond the age of 30 years. And so let's take a look here, for example, if we go up here at the attained age of 80 and you draw the line up, we can see that the Adventist men, the probability of their surviving is about, what is that? Is about 70%, I think it is. And then for the non-Adventist California men, their probability of survival is much less, about 60%. This one is the survival of California Adventist women and other California non-Adventist women, again, beyond the age of 30. And if we look again here at around age 87, we see that the Adventist women have greater survival than the California non-Adventist women. Okay, and this is this is a life table where where it's been calculated the percentage of survival to age 65 or age 85 among males and females. And I want to draw your attention now to the last three rows here, where go through this table with you. Let's just first look at this column here, the percentage of men surviving to age 65. Among U.S. men, that's 72%. Of the U.S. men are surviving to age 65, and when you compare that to California Adventists, it's higher, much higher, 87%, and then among California Adventist male vegetarians, it's even higher. Okay, those who are males surviving to age 85, among the U.S. men, it's about 20%, and there's a dramatic increase just among California Adventist men, and then the male vegetarians. Right, and then here is a percentage of women surviving to age 65. You can see that there's many more who are surviving females than the males, but the comparison is really here. Okay, so among U.S. men, it's women, it's 84%, and then it increases just among the California Adventists, and even much more so among the female Adventist vegetarians. And we see the same pattern here among women surviving to age 85. So just to summarize that little, this section, the consumption of plant foods is associated with lower risk of ischemic heart disease and incidence of some cancers. Adventists in California have a dramatic extension of life expectancy, and California Adventist vegetarians compared to non-vegetarians appear to have higher survival rates. So now let me move on to the Adventist Health Study 2 cohort, which is our current cohort. Again, it consists of over 96,000 participants. Sometimes we say it's 97,000 because it depends on what we're trying to analyze. Okay, and so the cohort was established between 2002 and 2007, and we enrolled men and women age 30 and above. And we included people in the United States and Canada, so not just California. So this is a greatly expanded cohort. And because our main outcome is cancer in AHS2, then we also had the task of matching with every state cancer registry in the country, which was an enormous task and very costly. Okay, so the diet in the AHS2 cohort is very well characterized. And let me start out with the ones who are non-vegetarians. They're about nearly half of the cohort are non-vegetarians. And these are people who eat everything, and a lot of it, okay? And so then we have the semi-vegetarians. We have about 5.5% of those in the cohort, and they also eat everything, but much less so than the non-vegetarians. The Paschal Vegetarians, we have about 10% of them in the cohort. These are people who eat fish, but no meat or eggs. And the Lacto-Ovo-Vegetarians, we have about 28% of them in the cohort. They eat dairy and eggs, but not fish or meat. And the vegans, of course, they're the ones, and we have 8% in the cohort. They are the ones who do not eat animal and dairy products at all, ideally. And if they do so, it's in very small quantities and not intentionally, we think. They're probably the hidden ingredients in some processed foods. Okay, so this is looking at the dietary pattern distribution by race, and what we see here is that the blacks, a proportionately higher, proportionally more blacks compared to whites are pescos and non-vegetarians, and a higher proportion of whites compared to blacks are semi-lacto-vegetarians and vegans. And this is the distribution of the dietary patterns by age group. And we see here that the younger cohort, those between 30 and 50 years, tend to choose a non-vegetarian dietary pattern. And the older cohort, 76 and above, tend to choose lacto-ovo-vegetarian and the vegan dietary patterns. Okay. So now moving on to some how relationships between the vegetarian diet patterns with metabolic syndrome, hypertension, and diabetes. Here, this is this figure compares the components of a metabolic syndrome across three different dietary patterns. Here we kept the non-vegetarians as we've defined it, and so the semi-vegetarians, but we've collapsed this, the lacto-ovos and the vegans together here. And so what we are seeing from this slide is that compared to the non-vegetarians, which is represented here by the black bars, that vegetarians have statistically lower significantly and statistically lower triglycerides, glucose, systolic and diastolic blood pressure, waist circumference, and BMI. And that from the same study, we found that the prevalence of metabolic syndrome is higher among the non-vegetarians, that's nearly 40%, and the prevalence among partial vegetarians is slightly lower, and among the vegetarians, it's the lowest, only 25%. So I also had a chance to look at how the plasma total cholesterol differs across the different dietary patterns. And to my surprise, I found no difference at all. Okay, they overlapped. And this was really almost disappointing at first to me. Okay, but despite that, we see that the levels, even among the non-vegetarians, the levels of total cholesterol was within the recommended limits. Okay. So this one is looking at a cross-sectional, looking cross-sectionally at the relationship between the dietary patterns and hypertension. And so in this analysis, the non-vegetarians were used as the reference. Okay, and so what we found here is that the lacto-ovo-vegetarians and vegans were associated with significantly lower odds of hypertension compared to the non-vegetarians. This, again, using the non-vegetarians as the reference, we found that the semi-vegetarians, lacto-ovo-vegetarians, and the vegans had an associated lower risk of incident diabetes, and these were all significant. Okay, to summarize this section, vegetarians compared to non-vegetarian dietary patterns are associated with lower odds of metabolic syndrome and hypertension and lower risk of incident diabetes. Now moving on to hard outcomes, if you will, mortality and cancer. So this was a study that, let me see, compared the dietary patterns, studied the association between dietary patterns and risk of all causes and cause-specific mortality. And we have put in red box here the findings that were significant. And what we found, and in this particular analysis, we collapsed. We used non-vegetarians again as a reference, and we collapsed all the other groups into one group, and that's the vegetarian group. And so we found a 12% reduction in mortality from all causes for vegetarians, and the effects was seemed to be stronger in men, and that's like an 18% reduced mortality risk from all causes. And the finding, although the direction it was in the same direction, but the confidence interval was too wide to make it significant. Now, when we looked at each of the dietary patterns separately, and again comparing them to the non-vegetarian as a reference, we found 19% reduction in mortality from all causes for pesco-vegetarians, and this again was, this effect was stronger in men. Okay. And you see it here. There's, how much is that? There is a 27% reduction in mortality from all causes for pesco-vegetarians. And then also for the vegans, lacto-ovos, and the pesco-vegetarians, we see a significant lower risk reduction from mortality from cardiovascular diseases for all of these dietary patterns compared to the non-vegetarians. So this is another survival curve here, and but this time we are estimating the probability of surviving without colorectal cancer, okay, at a certain attained age. And if we look at this, here we go up here, up to the age of 50, the probability of surviving free of colorectal cancer is the same in the vegetarians and the non-vegetarians. But after age 50, it starts to differ, where the vegetarians, aptly colored green, have a higher probability of surviving being free of colorectal cancer than the non-vegetarians. So now breaking it down to the 5 different dietary groups, and again here using the non-vegetarians as our reference group, and that is here represented as a line, horizontal line across here. And so if you see any of these crossing that line, that means it's not a significant finding. But what we found is a 43% associated risk reduction of colorectal cancer incidence among the pesco-vegetarians. Yeah. Okay, so what are the Adventists eating? Oh, no, excuse me, one more. I'm looking at my slide here. Okay, this now is looking at the outcome prostate cancer, and again, we see here that 35% reduction in prostate cancer risk for vegans as compared to non-vegetarians, but we did not find any significant results for any of the other dietary groups. And so now the question, what are the Adventists eating? Of course, the reason why they might have all these benefits from vegetarian diets may not just be due to the dietary patterns. It might be due to associated lifestyle habits that they also have, okay? But we're talking about diet, so let me show you what they are eating. And this figure is comparing the consumption of these selected foods among the semi-pesco, lacto, and vegans. And this is a relative mean quantity eaten of these food groups compared to the non-vegetarians. And here the non-vegetarians is represented by this line here. So the bars below or above means that they are either consuming, the other dietary groups are consuming less or more of that food. So let's take a look first at this group here of foods. These are plant foods. we see that compared to the non-vegetarians, that legumes, soy foods, and meat analogs, nuts and seeds, grains, and I will skip potatoes, avocados and vegetables and fruits are all consumed relatively higher among the semis, pescos, and the lacto and vegans compared to the non-vegetarians. But the potato intake is actually lower among the vegetarians compared to the non-vegetarians. So here, these represent the foods that are from animals or foods that we would normally consider being unhealthy. And so we're not surprised by this finding here that the meat intake is relatively lower among the semis, pescos, lactose, and the vegans compared to the non-vegetarians. The same is true for the dairy products and eggs, and also added fats, sweets, snack foods, and beverages. So, to conclude, compared to non-vegetarians, the vegetarian dietary pattern is associated with better metabolic risk factor profile. The vegetarian dietary pattern, compared to non-vegetarian, is associated with extended life expectancy and lower risk of colorectal cancer. And the vegan diet pattern, compared to the non-vegetarians, is associated with lower risk of prostate cancer. And last night, when I was preparing, finalizing these slides, I considered deleting or including this very last statement. And in fact, I thought maybe I should make it into a question rather than a statement. And I think I will make it into a question now because based on what I've presented, and we only represent one cohort, that do you think that it is time to consider plant-based diets as part of a community health promotion program? Okay. And that's my talk, and if you want to contact us, these are our contact information. And if you will allow me a little free advertisement for our school, we offer 4 different nutrition programs: Master of Science, MPH, and MPH Nutrition with a coordinated program in dietetics and a PhD in nutrition. Thank you.
We are scheduled for a break now, but I think we could take time for one question if someone has a really pressing question. But again, we'll have all the morning speakers on a panel this afternoon. Anybody have a burning question? Yes, ma'am.
Considering all the information that's coming out, I think it's mostly tentative yet, but about generational trauma and how generational trauma is sometimes specific to racial experiences or gender experiences in the U.S. I felt like in the conclusion stage, I could have maybe replaced some words and found the same results. Did any of that factor into the study?
So, well, how would you change it? I'm open.
Well, I think if you come from a home with a high ACE score, that's the childhood risk stuff. Like abusive,
okay.
Right? You're going to have almost the same metrics as you did for Seventh-Day Adventists or not. And then I also think that even though it's changing to a degree, a vegetarian or vegan diet is indicative of a particular class group. And so I think the benefits of being in a class group that has better health care, more preventative care, is also directly relative to those results.
Yes, okay. And that actually speaks to one of Tamar's comments earlier, where I think she posed the question, is there something in nutrition that everyone in this room can agree on? One statement that can be applicable to everybody. So just by your statement there, and I think for those of us who are in nutrition research, it's really difficult to have a one-size-fits-all kind of recommendation. So we have to consider all the other types of populations that are out there, those who have those who have particular medical conditions versus not, those who have a particular culture, a different culture, and so all of our efforts really should be considering all of these factors, and for health promotion programs, we really should be considering culturally tailored programs okay.
Thank you.
You're welcome.
All right, let's thank our speaker one more time. So we'll have a short break now. The program says 15 minutes, but if we'd like to change that to 10 minutes if you could, so that we stay on time. So we'll be back here in 10 minutes to hear about the environmental influence of vegetarian versus omnivorous diets.
So should I keep my slide open in case?